Hey guys, Mr. Betts here. I'd like to take a look at a couple examples where we're taking higher order derivatives. So in this particular example, we're given f of x and we want to find the third derivative of f. So we're going to start by taking a first derivative. First derivative, this is no different than we would have done earlier. We do need to use a chain rule in this problem with the e to the 2x. That 2 to the x is an inner function or a baby function. So we take the derivative of the outer function, derivative of e to the x is e to the x, so we're going to have e to the 2x. We leave the inner function inside, and then we're going to multiply by the derivative of the inner function, which is going to be 2. So now with the higher order derivatives, we just take the derivative of that. So notationally, we're just going to, since I use prime notation, I'll just stick with that. So I'll say f double prime to represent the second derivative. And so taking the derivative of the e to the 2x, we're going to get the same thing, 2e to the 2x, and then the constant multiple rule, that 2 is going to tag along. So we're going to have e to the 2x times 2 because of the chain rule, and then times the 2 because of the constant multiple rule, and we get 4e to the 2x. And we're looking for the third derivative, so we're going to go one more time here. And we could say f triple prime of x. That would be acceptable notation, or you can use the notation used in the problem here, that 3 in parentheses, they mean the exact same thing. And so same thing's going to happen. That 4 is a constant multiple, the e to the 2x, we're taking the derivative using the chain rule, which is going to be 2e to the 2x, and times the 4, we're going to get 8e to the 2x. So the third derivative of this function is going to be 8e to the 2x. Second example, we're doing the same thing. Notation looks a little bit different here. So now we're using Leibniz notation, using those differentials. But this notation means that we want to find the third derivative of y with respect to x. So again, we're going to start with just taking the first derivative. In this example, we're going to have to use the product rule. So I'm going to use the notation that is given in the problem here for a derivative. So dy dx is equal to derivative of the first, derivative of sine is cosine, times the second, plus the first times the derivative of the second. Now, just thinking ahead, if we're going to take the derivative again, I want to make this function as simple as possible before I take the derivative again. We can go ahead and take the derivative of this and get the second derivative. I think it would be easier if we rewrite this by factoring out the e to the x. And that's going to allow us to do the product rule one time instead of two times. So if I left it like I had here, I would have to use the product rule on the first term, and I would have to use the product rule on the second term, so I'd have to do the product rule twice. If I use this rewritten version, then I can do the product rule just one time because I only have one product. And then taking the derivative of what's in the parentheses here is a matter of using the sum rule, which is quite a bit simpler than the product rule. Regardless of how I do this, I should end up getting the same answer. So I'm going to take the derivative of the derivative in this form. So second derivative with respect to x. And we're going to be using the product rule here. So derivative of the first, derivative of e to the x is e to the x times the second plus the first, e to the x, times the derivative of the second. So the derivative of the second is going to be derivative of cosine of x, which is negative sine of x, plus the derivative of sine of x, which is cosine of x. Now I'm going to have to take the derivative again, and I'm going to do the same thing. Just thinking ahead here, I would rather do the product rule one time versus two times. This one here, when we simplify, is actually going to get quite a bit simpler because the e to the x times sine of x here and the e to the x times negative sine of x here, those are just going to cancel each other out. And then the cosine of x and the cosine of x are going to combine. So this is the same thing as 2e to the x cosine of x. So I can just do the product rule one time. When I do the product rule, I can tie that 2 to the e to the x, or I can tie it to the cosine of x. It really doesn't matter. So I'll just keep it in that form. So the third derivative of y with respect to x. So derivative of the first is going to be 2 e to the x times the second, cosine of x, plus the first, 2 e to the x, times the derivative of the second. Now, if this is a free response question, I can box it. It's not a real pretty solution, so I might do some rewriting here. I definitely wouldn't want to do that if it was free response, but if it was multiple choice, I would have to match an option, which would probably look more like this. I would imagine the 2 e to the x would be factored out, and then the cosine of x minus sine of x. So this is likely to be the way the answer would look if it were multiple choice, but free response, that is a perfectly acceptable answer right there.